An equilateral triangle has center O and side length 1. A straight line through O intersects the triangle at two distinct points P and Q. The minimum possible length of PQ is one of these quantities. Okay. So there's our equilateral triangle with a center of O. I was almost going to complain that I'm not sure what you mean by the center of a triangle, but I suppose with an equilateral triangle it's pretty much well defined. Side length is 1, and I am drawing a straight line through O, through this point, which clearly intersects the triangle at two distinct points, and I want to minimize that. My intuition is that it's going to be the line parallel to one of the bases. If we draw the line like this, that's probably the longest line, right? Because if I rotate the line that way around the center, this point gets closer to the origin, and this point gets farther away, but this point gets closer faster than this point gets farther away. So, I'm pretty sure it's just going to be the straight line which is parallel to one of the base, to that base. I'm going to go with that and just assume that that's the correct answer. Let me draw it this way instead. It's a little bit more convenient to look at. And I have a hard time convincing myself that this would not be the right answer, or the line that attains the minimum. Okay, so now I basically just need to find the side length of that base, right? And there's something so I don't remember for an equilateral triangle. I don't remember the ratio of the height to this sort of intermediate height. So you might just have to compute everything here. Let's drop this line down like that. Might be convenient. Okay. So this is 1/2. I'm going to call that x. We need to find x and then multiply it by 2. So that would be the point P, that would be the point Q. Okay. Height of the triangle. So we have h over 0.5 is equal to tan of 60 degrees. H is tan 60 degrees. Half of that. Pi over 2 pi over 3 and pi over 6. So how does this work? 1 goodness. Is that right? For right triangles, if I divide everything by root 3, that would mean sine of pi over 3 is root 2 over root 3. That sounds about right. Sine of pi over 2 is 1. Okay. So tan of 60 degrees is root 2. Okay, so h is 1 over root 2. Does that help? Suppose, you know, it would be helpful to also have, so at this point, if I had the quantity y, I'd be done. Where is the center of an equilateral triangle? I guess what I really should have done something like this. So that's 30. That's yeah, and this quantity, don't need that right now. Let's call this h prime. Tan pi over 6, 1 over root 2. Okay. So this says that y is equal to 1 minus this. And x is a scaled down version of this side. So h over y is equal to half over x. Let's write this as y over h is x divided by a half. Okay, 1 minus 1 over 2 root 2 divided by h, which is 1 over root 2, is equal to 2x. Two x is what we actually want to solve for, right? So let's just expand everything we have here. So that cancels. So I have 2 root 2 minus 1 over 2. This does not look promising. This is not one of the answers. That's because this triangle is wrong. I've done this before. Oh my god. 2, 1, and root 3. Oh my god. Okay, I mean, the process is exactly the same. It's just getting the numbers right. Okay. What did I have? H is equal to tan pi over 3 over 2. So H is equal to root 3 over 2. H prime is equal to tan pi over 6 over 2. So that's 1 over 2 root 3. So y is 1 minus 1 over 2 root 3. And what did I have before? X over a half is equal to y over h. And h is root 3 over 2. I'm still not getting something that looks like what I want. Oh, I see what I was doing wrong before. The height of the rectangle is not 1. Oh, God. Okay. So x divided by a half is equal to y over h. Is this one of the answers? 2 or 3? Yes, this is answer D. Okay. Large number of stupid mistakes that I don't know what I was thinking here. I mean, you never use these trig right angled triangles. You never have to worry about those, you know, after secondary school. Just who cares? So, I've forgotten these. I used to have them memorized like a very quick memory for them, but I haven't used them in 20 years, so I don't remember what those are anymore. But computing the value of y, I screwed that up many times because for some reason I was mistakenly calling that length 1. So I was doing 1 minus alpha equals y, and it's obviously not 1. Anyway, there you go. Just a bunch of geometry and tedious computations. There's really nothing special here. If I have another mistake, though, I'll let you know. Thanks for watching.